evaluate functions. Evaluate a function at an expression. So when we're placing a variable, we always use parentheses, which is what we did in the last video. Then what is inside of the function, right, replaces the variables. So let's look at an example. Example 1, we have f, then inside the parentheses is a variable d equals d pi. So we've seen this before, right? This is just a circumference of a circle, but we're going to find the function as 2r. So what this means is that this 2r right here is going to replace any time we see a d. So what does this look like? So f of 2r instead of d, anytime we see a d, now we're going to place 2r there. So we have d, so we're going to place it as 2r. We're going to put it in parentheses, and then it's just pi. So what's our answer? 2r pi. Or we kind of say it as 2 pi r. But this is, right, this is just the circumference. So we've done things really similar. We substitute, instead of the diameter, we're going to go 2r, because 2 times the radius is equal to the diameter. So it's something we have seen before. We have done this. It just looks different now in this way. So now let's look at another example. Example 2. So we have another function, right, that's p of n, which the function is equal to n squared minus 2n plus 5. So we're going to evaluate the function when n now actually becomes, right, n minus 3. So that's what we're looking at. So we're going to insert that anytime we see an n. So we see n there, those two spots. So we're going to insert this. So let's go ahead and do that. So we have p n minus 3, which is equal to n squared. So instead, we're going to put n minus 3 squared minus 2, now n, which is n minus 3 plus 5. Now we're going to go ahead and start to work on this. So let's deal with this. So, right, n minus 3 squared, really, that's what this looks like, right? We're having two copies and we're multiplying them together. Then we can go minus 2 and minus 3 plus 5. Now let's remember FOIL. So, right, FOIL means we start with the first ones. So n times n is n squared. We'll put that in parentheses. Next, we're going to deal with the outside, right? So FOIL. So the O stands for outside. So n times this whole negative 3. So we have minus 3n. Then we deal with the inside. So we deal with this negative 3 times n. So it's another minus 3n. Then we deal with the last ones. So negative 3 times negative 3 is then positive 9. So let's just keep that all in parentheses. Then let's distribute this negative 2 to the n and then to the negative 3. So negative 2 times n is just minus 2n. Negative 2 times negative 3 is plus 6. Then we just have this plus 5. Now what I like to do is kind of underline terms. So notice we have an n squared here. We don't have any more other n squareds. Then we have n. So we have an n here, and just an n here. So we need to add those together. Then we have just some numbers. So I like to sometimes just do squigglies. So this just helps me keep track of what do I need to all add together. So our last step is to add all of them together. So we just have n squared, so we can just leave as is. Then we have negative 3n minus 3n, which is negative 6n, minus 2n is negative 8n. Then we have 9 plus 6, which is 15, plus 5 is 20. So when we evaluate the function as n minus 3, we get this as our solution. Another example. What if we have this example? So we have a function, which is g of b equals, so our function is b squared plus 3b plus the square root of b over 4. So find when g is a squared d. So once again, we're going to plug this into anytime we see a b. So let's go ahead and rewrite this. So we have g a squared d, which is equal to, now we have b squared. Well, b squared now becomes a squared d. Put this all in parentheses. And that whole thing is squared, right? Plus 3a squared d, which we put in parentheses, plus the square root of a squared d all over 4. So now let's go ahead and simplify. So we have a squared d, which is all taken to the square root of that. So now a squared, we're going to deal with each variable by itself. A squared and then squared again, it just becomes a to the 4th, right? All we're saying is that we have, essentially, if we show it like this, when we take the square root, this is what that means, right? So we have a squared, d, and d. So this just becomes a to the 4th, d squared. This is just kind of like a little review. Call it review. So now we have a to the 4th, and then we have d squared, because now we have 2 d's. So we have it like that. Let's move on. Let's just go ahead and add this. 3a squared d, and then plus, now we have the square root of a squared d. Well, remember when we take a square root of anything, it's really asking, what do we have two things of? Like if we take the square root, right, the square root of something, like 4 squared, that's equals 16, but when we take the square root of 16, it goes back to 4. So basically we have like 2 copies of a squared. So one can pop out of the square root, and then we're left with just 1d. So that stays in the square root. We can't take it out because we have to have 2 copies of it essentially with the square root. And this is all over 4. So we have simplified this a little bit further. Now we look to see if we have any common terms to see if we can simplify further. And we see that they're all 3 very different terms. We can't actually do any more. So this is actually our answer when we evaluate this function. This whole thing. So when we evaluate this function as a squared d, we get this. So we just get this answer. So just because it's really large and we didn't simplify further doesn't mean it's not the right answer. This is our right answer because there's nothing further to simplify.